Hello everyone. So today we are solving another question of JEE ADV 2015. This is on the topic of rotational motion. So let's first read the question. They are given a ring of mass m and radius r which is rotating with angular speed omega about a fixed vertical axis and passing through the center O with 2 points masses each of mass of m by 8 at rest O. These masses can move radially outwards along two massless rods fixed on the ring as shown in the figure. At some instant the angular speed is okay 8 by 9 omega and one of the masses is at a distance of 3 by 5 r. At this instance, the distance of the other mass from the O is. Okay, basically this question is belonging to like conservation of something. What is conservation? Conserved here? It is here. Since there is no external torque here, so angular momentum will be conserved here. Angular momentum will be conserved here. Okay. So what is our angular momentum for a ring? It should be equal to I omega here. So initially, if you see the particles are at, let me draw this diagram first. Suppose this is our axis, okay, and we have a ring here, okay. So initially, all the particles, those two particles of masses m by 8 are at the center. So it means their moment of inertia is nothing but m into 0 square, that is 0. So initially, there is no contribution of them in the angular momentum. So let's write what is initial angular momentum. So angular momentum initial, okay. Initially, it should be equal to what is I of a ring? It is nothing but mr square. And what was omega initially? It was omega. So after some time also, when the particle moves radially somewhere here, this particle moves here, this particle must have moved there. So when they have moved there, then also the angular momentum should have been conserved here. So we'll write what is the angular momentum after some time when they have moved some distances. Okay. So let's write they have omega of 8 by 9. So that should be mr square 8 by 9 omega plus it is at the distance of 3 by 5 r. So it means it has mass of m by 8 into 9 by 25 r square into 8 by 9 omega plus some another mass which is m by 8 at a distance of xr. Uh, can we find like they have asked for the in the form of r only. So let's write the distance as x square, okay, into 8 by 9 omega. Now this should be ultimately equal to mr square omega. So let's sum up them all. Taking common of m r square, let's write it in the form of n square. We'll find the value of n only. N r square, okay. We'll have to find the value of n here. Mr square common, then 8 by, okay, we can take omega also common. 8 by 9 plus, this is 9 by 25 into 8, that is 200. Okay. Okay, basically there is a 1 8 by 9 also. So this is 9 at 72, it is 200, 1800. 72 by 1800 plus, here it should be 8n by 72. Okay. I think this is perfect here. Also, there should be an n square because n times r, that will be also in the square form. Okay, so I cannot forget this. Now this should be equal to mr square omega. If we delete all the parts, so we'll get this should sum up to 1 here. Okay, so if we like subtract from 1, so 8n square by 72 is basically n square by 9 only. N square by 9 should be equal to 1 minus 72 by 1800 can also be reduced further. 8 by 9 plus 9 8 times, and this is 200. Okay, so 8 by 200 and basically 8 by 200 and 4 by 100, basically it is 1 by 25. Okay, so if we sum them up, so n square by 9 should be equal to 1 minus what is 25 into 9, it is 29 180 225 and 8 into 25 is nothing but 200 plus 9 here. So 225 n square by 9 should be equal to 225 minus 209. So basically it is 16 by 225. Now if we square root both sides, so we'll get n by 3 should be equal to 4 by this 15 square. So we get n equal to 12 by 15, which is basically 4 by 5 times of the r. So our final answer should be somewhere D. Yeah, we have got our final answer 4 by 5. So this is our final answer. Thank you everyone.